Yes,
Yes,
sir.
sir.
Good morning, all of you.
Good morning, sir.
Okay, so we go for the further topic as we have seen several points of unit number 1. Just to have a look at the topics of unit number 1, and later on we will go to the next. So I'll share my screen. Is screen visible? I have a syllabus of first unit on my screen. Is it visible to you?
Yes,
No,
sir.
sir.
Introduction to system and control.
Yes, sir.
Unit number 1. Anybody who has say not seen this on their device?
Yes, sir. Yes. Now visible.
Everybody else? Okay. Today the Teams software seems to be somewhat slower at my end. So maybe the PPT reflected at your end. Maybe it may be say somewhat delayed. So till the time we have covered introduction to the basic definition of control system, closed loop and open loop system, transfer function, several numericals on transfer function. So यहाँ तक हमने portion cover किया है. Today we'll see mathematical models of physical system. In that electrical, mechanical and electromechanical system comes. And later on there will be one point in another lecture, of course, block diagram representation and reduction. And at the last there will be signal flow graph. Okay, basic control action is similar whatever we have seen till the time. So we will start with the mathematical models. Now here your attention is required because we are learning electrical and mechanical system as well. So you have to say little bit known to the Newton's law of motion. Okay, so without wasting time, we'll move to the today's topic. Okay, I hope you have PPT on your device, modeling of the system.
Yes, sir.
Okay, so this is the new topic, whatever we learn till the time. So modeling of the system, whenever there is system, as I said in earlier lectures as well, there might be any type of system, maybe say mechanical, maybe physical, maybe say electrical, electronics or electromechanical or anything in the world. Maybe the human, say this is also a system. So how to model that system? Because looking at the system, we have to analyze that, and before analyzing that, of course, we need some mathematical modeling of that so that we can work on that and we can understand a particular system. So here, what is model? I move to the next PPT. An electrical, sorry, an elemental or mathematical representation of a plan or a system, that is nothing but model. Model helps in analysis, that is what is input and what is output of the system. It captures the dynamics of the system. Dynamics refers to the revolution of the system variables. जैसे कि हमने, if we say RLC circuit, the system variable will be voltage and currents. So its dynamics is reflected everywhere at every branch and every node. Like an example, the room temperature when AC switched on. The speed of car when accelerated is pushed by certain angle or say distance. The evolution of current flowing through an inductor when voltage is applied. So these are the example. So whatever may be the plant or system, may be electrical, mechanical or electromechanical or electronics, its equivalent mathematical model is formed. And we are focusing on this part. Whatever may be the system, we are interested in mathematical models so that you can easily understand what is the system. Before going ahead, we'll see the types of mathematical models. Types can be differential equation of the model, जैसे हम KVL and KCL लिखते हैं in terms of RLC circuit or say electrical circuit. So dynamics of the system represented in terms of differential equation. Time domain representation of the system. Differential equation is nothing but time domain representation of the system. We have seen earlier also. Then another is transfer function model. We have seen this also. Dynamics of the system represented in terms of Laplace transform expression. We did this. This is not an unknown thing. And represented in frequency domain representation of the system. And another one which will be learned in unit number 5, that is state space model. This is also one of the model. Will be thoroughly, completely learned in unit number 5. So state is the set of variables that describe the system behavior in conjunction with the system inputs. Dynamics are represented by a set of first order differential equations using these state variables. We'll go say in detail regarding state space model, but here our motto is just to enlist the types. So types are differential equation, that is ODE, then Laplace transfer function and state space model. In this way we can model particular system. Example of mathematical model. It is very easy example to understand. I have a circuit R, L, C in series, wherein I of t is the current passes at time t and Vi of t is the voltage applied at time t. So let's see the differential equation. So differential equation will be, of course, it will be dV by dt is equal to R di by dt plus L d square I by dt square चाहिए यहाँ पे plus 1 by C. Of course, if you say apply KVL here, you will get similar differential equation. So in this way, differential equation model is represented. Then transfer function, we have already seen the transfer function of such kind of circuit converted into the Laplacian form, that is Vi of S, current is I of S, then R remains same, L converted into SL, and C, its Laplacian equivalent is 1 by SC. So output यहाँ पे दिया नहीं V0 of it, but output will take current, input is the voltage. Thereby output, that is I of S, upon input, that is V of S, will be 1 upon R plus LS or SL upon, plus 1 by CS or SC, whatever. So we know how to get this transfer function. We have seen 17 numericals based on transfer function. And similar, this differential equation can be written in matrices form or say state space form in this way. We'll not go in detail with this. So d IL by dt, dVc by dt, its particular components are minus R by L, 1 by C, 1 by L, here 0 multiplied by IL, Vc plus 1 by L, 0 into V. So this will be state space model. Don't think how it comes. It will be learned in unit number 5 in detail. Don't you worry about this. Just to know these 3 types, means for single system we can have modeling in these 3 ways, out of which these 2 ways are known to you, that is ODE, differential equation, and transfer function model, and third is state space. I'll move further. I hope my audio is clear at your end and the PPT is also visible.
Yes, sir.
Okay, thank you. Moving to the methods of modeling, you will find certain theory part in this topic. Methods of modeling. There are basically two methods, that is analytical modeling and another one is experimental modeling. We'll have small examples to understand this. Analytical modeling involves systematic application of basic physical laws, जैसे अगर electrical circuit हो KVL, KCL, ohms, whatever, to the system component and their interconnections. अगर mechanical system रहा तो it will be Newton's law of motions and everything. Combination of physical and mathematical modeling is also possible here. Then experimental modeling is another one where selection of mathematical relations which best fit the observed input output data of the system. It is also called modeling by synthesis. So we'll have an example of this. First of all, experimental modeling. Very simple example. I have a voltage source, DC voltage source connected to the resistance. Of course, as the voltage is applied, current I will pass. I will use this voltage source variable. I will vary it from 0 volts, it say to 20 volt with the step of 1 volt. So 0, 1, 2, 3, 4 up to 20. Suppose we have the model circuit by we are applying 0 to 20 volt to the resistance of 1K. Conventional steps of performing experiment will be applicable. So after application of this voltage, what will happen? As the voltage is increasing towards 20 volt, the current is also increasing. If there is 0 volt, current is 0. If there is 1 volt, so 1 volt divided by 1K resistance, 1 milliampere current passes. Similarly, 19 volt divided by say 1K resistance, 19 milliampere current will pass. And if you plot the VI characteristic, you did this in the experiment in second year or maybe in 12th and first year in electrical engineering, and we are plotting VI characteristic, that is voltage versus current. So your graph will be very linear. These are the readings where dots are showing the observations. So this is what experimental modeling. So by this we can easily identify this system is linear. If particular input is applied, proportional output current is generated. And simply we can have what? That is I, क्या find out कर रहे हैं हम? I is equal to V by R, Ohm's law. So its mathematical equation is I is equal to V by R. Intentionally I took very simple example to understand. And if somebody asks in examination to explain what is experimental modeling, there is no say restrictions. You may use any example, suitable example to explain this. Then it is very easy, experimental modeling. But what is another is analytical modeling. We have to think of several say parameters while using analytical modeling. First of all, we should know what is the purpose of model. जो भी हमारा model है, maybe mechanical, electrical, its purpose should be known. Then define boundaries. Boundaries define करना means it will be of course covered later on in detail. Boundaries define करना means it will work within particular say levels. इतना ही voltage रहेगा, इतना ही current रहेगा. Those are nothing but the boundaries. Then postulate a structure. We'll see this point say while explaining particular example. Then select variable of interest. What are the variable? Current, voltage, force, torque, likewise displacement, angular displacement. Then mathematical description of each model element. This is also important. We derived mathematical equations so that we can easily identify what is the system. Then apply relevant physical laws. Of course, mathematical equations ले रहे हैं, we should know KVL, KCL in terms of say electrical modeling. And if you are going for mechanical, then Newton's law of motions, whatever are required. Then after, of course, after this, what you will get? A final form of mathematical equation or mathematical model, we can say. So final form of mathematical model is ready with you at this step, but you can analyze that and validate कुछ गलतियां है या नहीं. Accordingly, you can analyze and validate. And after analyzing and validating that particular model, If necessary, you can modify the model, else you may stop here itself. You may stop here itself. So these are the certain steps in analytical modeling, maybe ask for 5-6 marks into the examination. Now we'll go into the each and every steps, whatever I spoke during the earlier PPT, this one will go in detail. So first, purpose of the model. The model to be developed should be decided based on intended objective. Objective क्या है उसका? Example, model of transformer to study losses and efficiency versus model of the transformer to study magnetic behavior and core saturation. Purpose क्या है समझ में आ गया. Then define boundaries. Next step, system of interest is separated from the rest of the world, referred to as environment by a boundaries. Boundaries may be real or imaginary. जैसे कि if we are designing, say our system is the AC, room AC, so we have to think of the boundaries. What are the external environment that affect on the system performance, or like how many people may be into the room and what will be the effect on the temperature, room temperature. Accordingly, system has to say take an action to correct itself. So boundaries for every system or subsystem should be defined based on the purpose. Then postulate a structure: system store, dissipate, transfer, transform energy from one form to another. Identify simple elements which characterize these operations on energy. Model elements generally have two ports, sometime or more, means two ports means input and output, and sometimes will be multiple input and multiple output. It may be possible. Represents the actual system as an interconnection of these elements. Structure postulate करना क्या है? Interconnection of particular element. RLC है तो RLC, whatever are there. And refer to as physical modeling. जो भी हम circuit वगैरह देखते हैं, we can say that is the structure. We'll see certain mechanical system as well. Am I audible at your end?
Yes, sir.
Okay. Okay, so I'll move to the next PPT. The fourth step, select variable of interest. First step of mathematical modeling, क्योंकि हमें जब तक variable पता नहीं, जैसे कि RLC circuit पे you are working and you don't know what are the variables, right? Whether it is current, force, elements क्या हो गया RLC circuit में? Elements are R, L and C. Whatever are the components we are using are the element. Like in mechanical system, we have say mass, then spring, damper. These are the elements. But variables are force, torque, displacement, likewise. So here the first step of mathematical modeling, you have to select the variable. जैसे कि RLC circuit है, voltage, current, whatever. Assign variable to all system attributes of interest. Example, current, voltage, velocity, temperature, etc. Then math description of each model element. इसका सबका mathematical description. Of course, we will be using laws here, rules here. Identify the relation between the variable at each of the model element. Relations may be differential or algebraic expression, of course. Then sixth step is apply physical laws. The most important step in getting mathematical model. Develop expression means first you may be thinking sixth step में भी वही बता रहे सर, fifth step में भी वही बता रहे. No, first means जो भी आपके variables है, if I have resistance, current and voltage, we specify that resistance value is equal to V by I. वो particular element के लिए हमने सोचा है, that is the description of say that element. But whenever complete circuit is there, R, L, C together are connected in certain fashion, and we apply certain physical laws like KVL and KCL, and after that we will be getting maybe say differential equation or algebraic equation. Those equations will get after application of physical laws here. So the most important step in getting mathematical model, develop expression to describe effect of element interconnections, then physical laws describes these effects. Example KVL, KCL, Newton law, thermodynamics, energy conversion, etc. Next is the final form of the mathematical model. Of course, all the equations resulting in step 6, previous step, put together form the mathematical model of the system, and possibly it is in simplified form. Another last but one step is analyze and validate the model. Model is never exact representation of true system. Verify the accuracy of the model if possible. Comparing model result with actual result for some input and output condition. Validate कैसे करते हैं? Like we are talking about AC. If it is open loop, what will happen? We'll turn on the AC, it will increase, say it will maintain certain room temperature. Then it is not under control. If some disturbance is there, like few people comes into the room, the temperature will increase. But as it is open loop, it will not understood by the system. But whenever generally a closed loop system is used, whenever a closed loop system is used, everything is taken into consider. What are the different input, what are the different disturbances or noises, those are taken into consideration, and accordingly we will try to get the validation of particular model. Just say I have a resistance 1K and I'm validating that. I'll apply 1 volt, then I am expecting 1 milliampere current. I apply 2 volt, I'm expecting 2 milliampere current. But have a think of the temperature. I'm doing this experiment at room temperature, ambient temperature. Then the readings are, say we are getting the readings, suppose 1 milliampere, 2 milliampere likewise. But if I increase the temperature to say 50 or 55 degrees centigrade, whatever, and at that time if we are performing the similar experiment, your readings may somewhat deviate. So you have to analyze and validate the model and modify the model if necessary. To be done if results in above steps are not convincing. As I said, validate करते वक्त आपको expected result नहीं आ रहा है, then you will again go through 1 to 7 step to validate it.
म्हणजे जर तुला समोर त्रास झाला तुला न्यास लागेल हॉस्पिटल मग चालते का नंतर गया पडल्यावर
ओंकार बोढे
आता आला पण तुला
ओंकार बोढे Okay, so these are the 9 steps of the analytical modeling. Now we'll go one by one. Mathematical model of the physical system. What are the different physical systems? Electrical system, mechanical system, electronic system, hydraulic, thermal. So each of these system can be modeled in terms of certain basic element. Basic element of all physical systems can be shown to be analogous. Now you might be thinking, itna sab dikha diya sir ne, we will be only thinking of this electrical, mechanical and electromechanical. Okay, so just read the last line, that is basic element of all physical system can be shown analogous. Can anybody tell me what is meaning of this analogous or analogy? Any of you? I will be happy if somebody tells me some, say it's a dictionary meaning or say anything about analogy means or analogous means.
Sir, random in nature.
Okay. Any other answer? Because we are working on this analogy of the system. Any other answer from anybody?
So it is similar.
Yeah, it is similar. Like if we are talking about the flight or aeroplane, so aeroplane wings are analogous to the bird's wings, right? Both functions are same. Though aeroplane is say automobile or mechanical system we can say, and birds are say live animal, right? Live things, living things. So, but whenever birds wanted to turn or fly, whatever, similar action can be done in case of aeroplane, because the wings are made analogous to bird wings. Aeroplane wings are made analogous to bird wings. उसका पूरा functioning देखा है कि क्या होता है ऐसे ऐसे करने से, how to turn, how to take off, how to land. So everything is analogous. So likewise, we can have analogy of say electrical system to mechanical system to electrical. So that will be learned in next PPTs. Okay, so same PPT, elements of modeling. We have electrical system classified based on type of the source. Of course, I have electrical system, but how those are classified? Of course, the basic elements are same. That is R, L, C के बारे में बात किया तो here also R, L, C are the basic element. But the source may be voltage or it may be current. So those are classified into, that is voltage source system and current source system. Let's have comparison table. Voltage source system and current source system. The basic elements are same, RLC in both, but the basic system variable, as I said here, elements are nothing but a component. System variable means we are applying certain system variable, accordingly system will change the output or whatever are the parameters. So in voltage source, we have voltage and rate of change of charge, that is Q. So variables are voltage and charge Q in voltage source system, and in current source system we have variables, that is current and change of flux, that is phi. So only two classification in electrical system, voltage source and current source. Then elements, resistor, actually padna bhi nahi chahiye, it is very easy, is an element which resists the flow of current. V is equal to IR, you know. Capacitor is an element which stores an electrical energy in an electrical field. That is, you know these relations. I is equal to rate of change of charge, that is dq by dt, is equal to C dV by dt, that is C into rate of change of voltage with respect to time is nothing but current. Then where you can see charge is directly proportional to the voltage, and you can write this equation, Q is equal to C into V, which is a linear relationship between charge and the voltage with constant C, that is capacitor. Inductor is an element which stores an electrical energy in a magnetic field. ये वाला electrical field में store करता है. Inductor stores energy in magnetic field, where voltage is equal to rate of change of phi with respect to time is nothing but inductor L into rate of change of current with respect to time, where you can see phi is directly proportional to current I, and you can write phi is equal to Li, that is the linear relationship between current and flux generated. So you might be thinking, why this PPT again, all 9 steps? So we'll be working on the electrical system and we'll be focusing on these 2 steps, that is application of relevant physical law and making final form of mathematical model. Let's have example. I have nodal analysis of electrical system. I have electrical system which is very easy. Current is applied to 3 elements which are in parallel, R, L and C. So of course it will have only one node, and if it will generate certain voltage if current is applied at this node, and as the current is applied to this circuit by a current source I, it will pass the current through resistance, that is IR, passes current through inductor, that is IL, passes current through capacitor, that is IC. So nodal analysis is very, very easy. Based on the Kirchhoff's current law, at any node in electrical circuit, the directed sum of current flowing in out of that node is equal to 0. So similarly, we written that I is equal to addition of all three currents, that is resistance, inductor or capacitor wala current. Putting the say mathematical formula to convert this current into the system element and parameter, that is it will be V is equal, sorry, IR is equal to V by R plus IL कैसे लिखेंगे हम 1 by L into V integral V dt, and IC it will be C into dV by dt. Substituting V is equal to what is voltage? Voltage is rate of, here actually current के बारे में बात कर रहे हैं, so we deal with flux. So V is equal to d phi by dt, rate of change of flux. Putting that value in place of V, so you can see I will be equal to C into d square phi by dt square plus 1 by R into d phi by dt plus phi by L. So finally, this one, this is your final mathematical model where you can see it is a differential equation form where you can see we have elements, that is RLC, and we have what relationship between current and flux. So therefore the basic element of the system R, L and C, the variable of the system are current and flux. Let's have another, that is loop, that is KVL analysis of the system. So loop or mesh analysis of the system uses KVL, that is based on Kirchhoff's voltage law. At any loop in electrical circuit, the directed sum of voltages around a closed loop is equal to 0. So you can see similar circuit is there where instead of voltage current we have applied voltage here, and RLC are connected in series. If voltage is applied, some current will pass. It will generate voltage VR across resistance R. It will generate VL across resistance, sorry, across inductor L, and generate capacitor voltage VC across capacitor C. And there is only one loop. You can see here there is only one loop. So writing loop equation, your applied voltage will be equal to sum of all voltage drops into the elements. So V will be equal to VR plus VL plus VC. We'll write this voltages in terms of current. So VR is nothing but I into R. VL is nothing but L di by dt, rate of change of current into inductor. And Vc is nothing but 1 by C integral of I dt. So we converted into, say, this form. Then we substitute current I is equal to dq by dt. So here rate of change of charge, because voltage and charge we need. So V will be equal to L into d square by q dt square plus R into dq by dt plus q by C. So this is the final form of this electrical model. This equation is the final form. So therefore, the basic element of this system is RLC, of course, and the variable of this system are voltage and charge. We're going through very basic things so that solving problem based on this will become very easier. Similarly, as we have seen what electrical system, there are two types classified based on voltage sourced system and current source this system. Accordingly, we have seen the relationship between voltage and charge and current and flux likewise, and we derived a mathematical model of voltage sourced and current source system. Similarly, here is the mechanical system classification based on type of the motion. So one is translational system having linear motion, a classification due to linear motion, and rotational system having angular motion across fixed axis. So there are two classification, translation that is linear and rotational that is angular motion. System element क्या रहेगा दोनों इसमें? Here is in translational we have mass, then damper. Damper is nothing but, what is damper? Can anybody explain? One line statement for damper. What do you mean by damper? Damper is nothing but a friction. And linear spring, which will have potential energy there. So these are the three elements of translational. Similarly रहता है, but the notations are different. Rotational में we have inertia denoted by J. We have damper here. Damper is denoted by D, and torsional spring denoted by K. Linear spring, you know what is linear spring. पेन में जो रहता है that is also linear spring. Then स्टेपलर में अगर आपने जितने भी लोगों ने स्टेपलर में पिंस इंसर्ट की है, that spring is also linear spring. And can anybody tell me what is the torsional spring? कहाँ पे रहता है? Yes, quickly. I'll wait for half a minute. Torsional spring कहाँ रहता है? Give me an example. Or what is a torsional spring? Of course, linear spring means it will give you the linear motion. Expand होता है, compress होता है तो. Torsional spring means it will give you, of course, spring action, but it will be angular. Anybody? I'm expecting one or two example. Am I audible to all? Am I audible to all? Hello?
Yes, sir.
Yes.
Yes, sir.
I'm expecting a small answer from your side. This is not rocket science. Anybody can answer.
Sir,
Torsional
clutcher
spring.
में
Yeah? Yes, yes, please speak out.
clutcher
What is that? What is that? I'm not getting. Don't hesitate. Please speak. What did
hair
you say?
clutcher. Sir,
Huh?
hair clutcher.
Yes, of course. Hair clip, that is clutch. Then also whatever the clips we are using for, say, holding bunch of paper, that is also having torsional spring. Then in, say, not digital but mechanical watches जो रहते हैं, there is also torsional spring. Again, small toys, mechanical based toys जिसे हम चाबी देते हैं और खिलौना जो भी है एक्शन में आता है, those are also torsional spring. So angular spring is nothing but torsional spring. So basic system variables here, force and the displacement, and in linear we denote displacement by x, and here in rotational angular torque, that is t, and angular displacement is nothing but theta. So this is the mechanical system classified based on type of motion, translational and rotational. Just have a differentiation between mass and the inertia. The property of element that stores the kinetic energy due to translational motion is nothing but mass. Inertia, property of element that stores the kinetic energy due to rotational motion is nothing but inertia. When force is acting on a body of mass m, causing linear displacement x, then your F force will be equal to rate of change of momentum with respect to time, where momentum can be written like this: momentum is equal to m into v, kg per meter per second. and velocity can be written like this: rate of change of displacement with respect to time, dx by dt. So putting these values here, it will be m d square x by dt square. ये बदलता नहीं है इक्वेशन. फोर्स इन टर्म्स ऑफ मास, अगर हमने लिखा है रिलेशनशिप फोर्स एंड मास का, इट विल बी एफ इज इक्वल टू एम डी स्क्वायर एक्स बाय डी टी स्क्वायर. सो इट कैन बी written mx double dot. Similarly, in terms of rotational, when torque is acting on a body of inertia j causing angular displacement theta, then torque is equal to rate of change of momentum, angular momentum. ये जो है ना, ये नोटेशन मैंने ऑनलाइन भी देखा है बहुत जगह पे. दिस नोटेशन इज डिफरेंट फॉर एंगुलर मोशन, say momentum. So I use L wherever I found it. So dl by dt, where L is nothing but j into omega. That is, j is what? J is inertia into angular velocity, which is kg meter square per second, and omega is nothing but d theta by dt. That is rate of change of theta with respect to time. Putting this here, we get relation torque is equal to j d square theta by dt square, and in short it is written j theta double dot. So we will be using this several times. Here you can see the pictorial representation, force and displacement, and here is the mass m. Here torque and angular displacement theta. So here is this, and here is a inertia j. So this is the small comparison on single PPT in between mass and the inertia. Then what is a damper? Damper is an element that generates force which acts opposite to the direction of motion. जिधर motion जा रहा है उसके opposite में act कर रहा है. Nothing but the resistance to the motion. Translation or rotational. Damper resists the motion. Example, friction or dashpot. Translational, rotational में हमें formulas लेना है. We will be using these formulas while getting the physical model of mechanical system, where F has a relation that is B. That is, B is nothing but damper in translational system. B into rate of change of displacement x dx by dt, and can be written b x dot simply. In rotational, we have damper के लिए d use करते हैं. That is, t is equal to d rate of change of angular displacement. That is nothing but b theta dash. Here is the symbols. This is the fixed, where this is the damper in translational force, where this is the displacement direction, this is the force direction, and this is the damper. And you can see here in rotational, damper में अंदर थोड़ा gap रखा है because it is angular motion. So theta, torque, and this is the damper. And these two are the relationship which we need to say remember. Then linear spring, that is K, versus torsional spring, that is also K, represented with K. Property of element that stores the potential energy due to translational motion. Here is property of element that stores potential energy due to rotational motion. Spring का काम है potential energy retain करने का. When a spring of spring constant K is applied to the force F, causing an elastic linear displacement X, then what is the relationship between force and displacement in respect to spring? It is F is equal to Kx, K times X. And similarly, when the torsional spring of a spring constant K is applied to the torque T, causing an angular displacement theta, then relationship between torque and theta in respect to torsional spring is T is equal to K into theta. So we have seen certain relationship, force and mass, that is force is equal to m into x double dot. Then damper and displacement. So here we got bx dot, F is equal to bx dot, and here spring and displacement, that is F is equal to kx. So wherever there will be say certain mechanical system you see, you will be using these rules to convert or get the mathematical form of the system. Nodal analysis of mechanical system. Please have your attention here. Nodal analysis. System structure should be modified to suit nodal analysis. अगर आपको कोई भी मैकेनिकल सिस्टम दिया है, you have to modify that to suit the nodal analysis without loss of system characteristic. उसमें से एक भी कंपोनेंट और एलिमेंट गलत नहीं लगाना है, कुछ कोई भी नोड वगैरह छूटना नहीं चाहिए, इंक्लूडिंग रेफरेंस नोड. Steps of analysis are detailed by example. Here is the example. I have a node 1 here. I have node 2 here, wherein spring K is connected. Force is applied in this direction. From node 2 to reference node, 3 elements are connected. One is damper, another is spring K2, and another is mass. M लिखना भूल गया मैं यहाँ पे. Another is mass connected here. So the number of nodes are 2. Here 1 and 2 reference nodes छोड़ के. Hence the number of displacement will be 2. So what I will do, I'll write 2 displacement, x1 and x2. So displacements and reference nodes are identified. एक ऐसा structure निकाल लेना है. These are the steps very easily say presented in this PPT, simply presented in this PPT. Next step, जितने नोड्स है उतने डिस्प्लेसमेंट, तो एक रेफरेंस नोड निकाल के जितने डिस्प्लेसमेंट है उतने x1, x2, xn whatever are represented like this. Next, connect mass between node x2 and reference node. You can see, I'll erase the ink. You can see this mass, this is the mass connected where? Connected between node 2 and the reference node. So ये node 2 and ये reference node, ये दोनों में हम mass connect करेंगे. Similarly 1 by 1 connect करना है component. So mass is connected between x2 and the reference node. Then connect spring K1 between node 1 and node 2, that is x1 and x2. So here is x1 and here is x2. Then I have connected K1. Similarly connect spring K2 between x2 and the reference node. ये है reference node और ये है x2. I have connected spring K2 here. Then connect force between node x1 and reference node. Connect force between node x1, here is node x1 and the reference node. और एक बचा है connect damper. Damper कहाँ पे? Damper is between node 2, that is displacement to x2 and the reference node. In this way you can see, let's see the previous figure. This is the previous figure. So system structure जो दिया है, it is modified to suit nodal analysis without loss of system characteristic. So we did here. This one is the suitable model for nodal analysis of the given system without loss of any characteristic of the system. Please add on one sentence. I will add it and later on upload it. Damper connect किया है यहाँ पे, कहीं पे मैंने mention नहीं किया है. B between what? Between x2 and reference node. So once this is finished, we'll apply the physical laws, and of course as it is a mechanical system we'll be using Newton's second law of motion. So apply Newton's second law of motion or at node x1. दो नोड है x1 and x2. पहले x1 पे करेंगे. x1 को क्या लगा है? x1 has a force, so F, and then connected component is k1, that is k1, and k1 is what? K1 has the impact of x1 as well as x2. So we'll write x1 minus x2. That's it. उसके बाद जो नोड है सभी x2 को कनेक्ट है. So here in this loop we can say I have only one element, that is spring K1, and I have force F and the effect of two displacement x1 and x2 on K1. So one equation is written. Another, I'll write equation at x2. I'll write equation as at x2. Let's see what are the connected component. x2 को damper connected है, mass connected है, and spring K2 connected है. Okay. फोर्स वगैरह यहाँ पे कनेक्टेड नहीं है दिस साइड में. सो अप्लाई न्यूटन सेकंड लॉ ऑफ एट नोड x2, दैट इज 0. फोर्स इधर से कुछ भी नहीं है, सो दैट इज 0 इज इक्वल टू मास का क्या लिखते हैं हम, यहाँ पे डॉट दिख नहीं रहा है पीपीटी में, इन एक्चुअल इट इज देयर. सो मास के लिए लिखते हैं m x डबल डॉट 2, सेकंड डिस्प्लेसमेंट के वजह से हो रहा है x2 डबल डॉट. देन डैम्पर के लिए लिखते हैं हम प्लस b x2 डॉट, देन स्प्रिंग k2, स्प्रिंग k2 के साथ क्या है, k2 हैज ओनली वन displacement x2, so k2 x2 plus you can see x2 को k1 भी connected है, so we cannot forget this, so k1 into उल्टा लिखना पड़ेगा x2 का इफेक्ट एंड x1 का, so x2 minus x1. These two equations gives the mathematical model of given mechanical system. So very simple, we had one mechanical system, we converted into suitable nodal model without loss of characteristics. Then we wrote the equation applying Newton's second law of motion. We whatever are the component, mass, damper, spring, accordingly we wrote that, and this is the final mathematical representation of the system. Then analogous system. Let me see the number of PPTs here. Okay, we can cover it. Analogies of the system. Analogy of system. Mechanical system can be represented using electrical element by following two types. अगर ये है mechanical system है, we may represent the same system using electrical component. So there are two analogies. One is force voltage analogies called FV, very important, please look at. Another is force current analogy, that is FI analogy. In force voltage analogy, it is also called torque voltage. Okay, force is analogous to voltage. As I said, birds wings are analogous to aeroplane wings. Here in force current analogy, the force is analogous to the current. Let's have an example. Very simple. This is the mechanical system where we can see force is applied in this way, mass is there, there is one node here, then one damper is there, one spring is here, and displacement in the direction of force. So based on the Newton's second law of motion for translation system, we can write F is equal to mx डबल डॉट, मास के लिए हो गया, एक ही है ना यहाँ पे डिस्प्लेसमेंट, डबल डिस्प्लेसमेंट नहीं है. देन डैम्पर के लिए क्या लिखते हैं हम, bx डॉट, एक ही डिस्प्लेसमेंट है, एंड स्प्रिंग के लिए वी हैव kx. सिमिलरली अगर हम रोटेशनल सिस्टम है तो क्या लिखेंगे, टॉर्क इज इक्वल टू जे थीटा डबल डॉट, डैम्पर डी थीटा डॉट, एंड स्प्रिंग प्लस के थीटा. नाउ बेस्ड ऑन द केवीएल ऑफ इलेक्ट्रिकल सिस्टम, यहाँ पे हमने केवीएल लगा चुके हैं ऑलरेडी, सो आई विल नॉट गो इन डिटेल. केवीएल लगा चुके हैं यहाँ पे, एंड वी गेट व्हाट, वोल्टेज. हम वोल्टेज के बारे में बात करें, एफ वी एनालॉजी, फोर्स टू वोल्टेज. तो हमें यहाँ पे मिला था V इज इक्वल टू एल डी स्क्वेयर, क्या मिला था, एल डी स्क्वेयर थीटा, सॉरी पाई बाय डी टी स्क्वेयर प्लस आर डी फाई बाय डी टी प्लस क्यू बाय, सॉरी क्यू नहीं, फाई नहीं, क्यू बाय सी. ये इक्वेशन मिला था. शॉर्ट में कैसे लिखा हमने, डी क्यू डबल डॉट प्लस आर क्यू प्लस क्यू बाय सी. देयरफॉर अगर इसे कन्वर्ट करना है, just see the relationship. Your force is nothing but voltage, so force is nothing but voltage analogous to the voltage. Mass is analogous to the inductor L, mass is analogous to the inductor L. Damper B is analogous to resistance R, and spring constant K is analogous to the capacitor 1 by C, inverse relationship between. And what, that is nothing but displacement x is analogous to the charge toward q. Displacement x is analogous to the charge toward q. So you can see these are the analogy, force to voltage analogy. Whenever we will be converting, we'll be using these rules. वैसे ही हम टॉर्क के बारे में अगर बात करें तो टॉर्क इज एनालॉगस टू वोल्टेज, जे इनर्शिया इज एनालॉगस टू इंडक्टर, डैम्पर डी एनालॉगस टू रेजिस्टेंस, spring constant K analogous to 1 by C, and angular displacement theta is analogous to Q, charge, of course. Another is force current analogy. So similar equation for rotational system, for translational system. For rotational system, I have similar relations in earlier PPT because similar system is there, one displacement. So based on KVL, this is the electrical equivalent analogous model. Based on KVL, I have I is equal to C phi double dot plus phi dot by R plus phi by L. Let's see the analogy. Here force or torque is analogous to current. Here mass is analogous to capacitor C. Similar kind of differential equation we can have. Then damper B is analogous to 1 by R. This is 1 by R. Constant K, spring constant K is analogous to 1 by I'm sorry, here it should be 1 by L. This is wrong. It is 1 by L. And displacement X is analogous to flux phi. Similarly, we may relate the rotational elements. Here theta will be analogous to flux. So I'll make it correct and I'll upload. This is not 1 by C. This is 1 by L. K is equal to 1 by L. Please make a note of this. So summary of the analogy system. Following table shows the analogy between elements of mechanical and electrical system. So we have mechanical system. Two systems are there: translational and rotational. Then force voltage analogy, force current analogy. You can see force is analogous to voltage in Fi. Force is analogous to current. Similar thing whatever we see. Mass is analogous to inductor for Fv, and it is analogous to capacitor for Fi. Damper is analogous to resistance in Fv. In Fi, it is inverse of that, analogous to 1 by R. Spring K is analogous to 1 by C in Fv and 1 by L in Fi. And linear displacement X is analogous to charge in Fv and flux in Fi. Similarly, you may see the relationship between the rotational system and FI/FV. Transformer, I'll have 2-3 minutes and then I'll stop. Transformer versus gear. What is transformer? Transmit electrical energy from one circuit to another through electromagnetic induction. But what is gear? Gear also transmit energy from one gear to another gear, but by mechanical, say torque वगैरह. So changes voltage level, here changes speed or direction of the motion. Relationship of transformer, you know, this is the symbol. That is V1 by V2 equal to N1 by N2 is equal to I2 by I1. Similarly, here gear के बारे में T1 by T2, that is torque of first gear, torque of second gear, equal to R1 by R2, that is rotation of first gear and second gear, equal to omega 2 by omega 1, that is what angular velocity of second to first. So I hope here we'll stop, and later on we'll see the remaining part of the only 2-3 PPTs are remaining related to this modeling of the system and force voltage and force current analogy का example हम next इसमें देखने वाले. If you have question, you have only 30 minutes. If no, then I will end this session. Thank you. Please ask question if you have.